Hello students, welcome to Advanced Deep Learning Lab. Today let us see the third experiment. Our third experiment is speech recognition. So you should give an input speech and it should be converted to a text format. Now let us take a deep learning model and we'll get the text output from our input. So before starting this session, we'll see the drawback of the old model. Previously in sentiment analysis, to find the sentiment of the input, we create a bag of word, right? So like this, we create a bag of word and these vectors are given input to this model and sentiment will be found like this, whether positive or negative. But here we have a problem. See the first sentence, this phone is no good, negative sentence. No, this phone is good, it's a positive sentence. If you convert to vector format, the bag of word will create vector like this. The disadvantage of bag of word is it does not consider the position of the word. But in speech recognition, you have to consider the position of the word. Now, can we use simply a neural network to convert our speech to text? There is a drawback with neural network. So here you see the vector size, input vector size, and see the output vector size. So if you are using any standard neural network, it does not work out to give for a sequential model because your speech is a sequential model. Your input may have n number of text, your output may not have same number of text because it is converting to a new language, correct? So the conventional model we cannot use. So we cannot simply rely on a feed forward network because it accepts a fixed input and print a fixed output. Now, what is the solution for this? Our problem is the sequence of input must be given to the model and your output may not have the same sequence or same number of words. The conclusion is this problem is solved with another neural network called recurrent neural network. For any kind of NLP based solutions, we can use RNN depending on the application. So RNN will allow to operate on sequence of vectors. The special thing of RNN is we have a memory, the previous thing, those memory will be retained and conversion can be done. Now let us see the architecture. Suppose you are taking one input, one image you are taking. From the image you want to identify cat or dog, which animal is present in the image. So that is an example of one-to-one RNN variant. So one image you are giving, one output you are checking. There are some other model can take one image as an input or one text as an input. From that many output you may expect. From one image you may find many objects. Our application is this many to one and many to many. Sentiment analysis. You collect many sentiment, that is sentence 1, sentence 2, sentence 3. From that you are trying to find positive or negative, that is many to one. Speech conversion is many to many. So you are giving an input speech in English language. You are expecting in English or maybe some other local language. So the number of words may not match exactly like your input. So that is this architecture, many to many architecture. Many to many also we have for different machine learning applications. Now we'll see the RNN architecture. RNN architecture is similar to your neural network architecture. It takes input, there is a hidden node and we have output here, but with every node we have a loop like this. The extended diagram of RNN you can see here. It takes input X, output is O, hidden state is S. We have a weight matrix U, V, W. But we have many hidden state here, correct? So this one you can see, if you are in the current state t, current time, the previous time t minus 1 and the next one t plus 1. So for each input you have output with a different weight matrix. U is your input matrix, B is your output matrix, W is your hidden matrix. So your RNN will retain the previous one depending on your application. How our lab program works, it takes the audio input in wave format. It will convert to a vector, X vector. The input is a wave that is converted to vector, that is spectrogram. So spectrogram will convert to vector format. We use a trained model. Here we are using two models, whisper and wave to vector 2 also you can use. Then you can decode to the natural language. Let us see the demo. Before that, let us try to understand how the input is given. Suppose if you have a sentence like this, Rama conquered Ravana to install the virtue of Dharma. So this is the word. We have a 9-word sentence. Each word, one-hot encoding technique we are using here. So each word is marked as 1. But if you have a very lengthy sentence, so that many words should be marked. Correct? So the teeth word of ith output sequence will be your Y. That is your output Y. So here how to retain the position of the word? Now from the starting to end, the big vector is here, that X vector, input vector is here. Assume that it contains 10,000 words. So 1 to 10,000 words, and the position of the word marked as 111. So here you can see the position of Rama is in this location. Position of Ravana, word Ravana is in this location. So the approach is one-hot encoding. So beginning of NLP we were using one-hot encoding. We were using a lengthy vector. This vector is given as an input to your model, RNN model. Then later we have used word embedding technique to find the similarity among words. For example, apple and orange. Word is different, but there is a meaning between these. Mean both are food, we can say. King and queen. Both are belongs to royal family. So like that, some syntactic meaning you can find. So that is based on word embedding. So here for all 10,000 words, some properties of the word will be identified. Here, for example, 300 dimension, 300 properties you can identify. So 300 into 10,000 matrix will be created. Depending on the application, you can create. So word embedding will form a dense numerical vector, list of number. Instead of your one-hot encoding technique, it reduces your input size. And now let us go to our demo program. So here is the demo program. I have already executed the program. So first line we are installing library files. So this library file will take care of your pre-processing. The text informations are added in the file. I will post same file in the Google Classroom. You practice the same program. So the wave input will be taken in spectrogram format, will be converted to token. I have given input like this. 4 wave files are there. The next library file, pipeline file, installed here. It is for automatic speech recognition. Same. It is for your pre-processing. And whisper model we are taking, that is stored in ASR. So after running this line, this OpenAI model, speech to text conversion model, is stored in ASR. Now this input is given. In English, one wave file is given. So you can generate your own text input, give that input to this file. and it is converted here. So this is the converted text. So the speech of English sentence is converted to text format here. So this is the text format. I have tried the same model with other local language. It is given in Tamil. This is the word file. I have mentioned which word is pronounced. We got the output, but not exactly. Still the model need more training. These OpenAI models are good for English and other standard languages. If you are using for any local languages, it may not be very accurate. 80% or 90% you may get. Then one more example I have tried. For Kannada also, this is the input I gave. Approximately similar output I got. And for Telugu, I have tried same whisper model. And this is the input wave file we have given. Output is 60% correct. All three inputs are not translated properly. Students can try a project similar to this NLP model. For any particular domain, you can collect text input, train the model, and try to convert to a text format. So that's all in third program. The summary of this program is, if you give an input in any language, that language will be encoded by your model. That vector is given, S is your input, and that is decoded and output is printed. So this is the example for a sequence model. So your number of input word may not match with number of output word. And here in our example, we have used a pre-trained model. Students can try your own model or same pre-trained model with your text you can train and check the output. Thank you. You practice the program and upload the PDF in the Google Classroom. Thank you.